Okay, Chapter 1, Section 2 notes are going to look at how we measure things to determine density. So when we're measuring units, remember that length is measured in meters, millimeters, or kilometers. Mass is always grams, kilograms, or milligrams. And in this class, we're typically going to use grams. Volume is liters, milliliters, or what we call centimeter cubed. And volume is determined by how it was measured. If you use a graduated cylinder, your units will be milliliter. If we take measurements of something that is got a length, a width, and a height, then we will use centimeters cubed. Temperature, no matter what, is Celsius. When we look at this term density, it's going to have the grams for the mass, and then either centimeters cubed or grams per milliliter for the milliliters based on if that volume was measured with graduated cylinder. Very critical to know how the volume was determined. When we're measuring matter, there's two terms to remember. Mass, which is how much matter is in an object. I like to say how much stuff is in the object. And weight, which is actually the force of gravity on an object. In everyday English, we use weight interchangeable with mass, but in class, we're talking mass. Make sure you understand both definitions, because here on Earth, we have 9.8 meters per second squared of gravity acting on us at all times. But if we were to go out to the International Space Station or go out to the moon, say, then our weight would be different because the force of gravity is less than it is here on Earth. If we were on the moon, our weight would be 1/6 of what it is here on Earth because there's less gravity there. Volume is the amount of space that matter occupies. So if you look at something like a marshmallow, depending if you get a small mini marshmallow or even go up to those giant marshmallows, there's not a lot of stuff in there. There's a lot of air taking up that space. So if you look at the mass and the volume, the density is very low. Versus if I take a big chunk of lead or chunk of iron, they're very condensed, so there's many molecules or many little atoms in the space, and so they're going to be heavier. When we measure the volume, if it's a regular shaped object, that's where you're going to measure with a ruler, length times width times height. If it's an irregular object, we use something called water displacement. So you start with a graduated cylinder, you put in a set amount of water, let's say 30 milliliters of water. You drop the object, the ending volume goes up to 39 milliliters. Well, that means 9 milliliters of that space is due to the object. So you take ending volume, subtract the initial volume to get the volume for that irregular object. So remember, we use centimeters cubed, cm with a little 3 if you measured with a ruler. You use a cc when we're in the medical field. If you've ever heard them say, give me 5 cc's of epinephrine on a TV show or something, that's when you're using centimeters cubed for a cylinder. And then we use milliliters, ml, when we use a graduated cylinder. Density is how much mass is in that given volume. So how much stuff takes up that space is an easy way to remember that. Now, the density of any substance is the same no matter what size the sample is. So if I have a small pebble of gold versus a big block of gold, it should still have the same density. If it's not, then you have something different. The way we measure density is one way to determine what a specific substance is. The density of gold is different than pyrite, and this is what they use to determine if a yellow rock that they brought in from the mines was actually gold or not. They didn't just say, hey, it looks like gold. They had to actually measure it. They would take out a 2-pan balance, put the rocks on one side, put weights on the other side to get the mass. Then they would take a tub, fill it up, get the measurement for the volume, and then take mass divided by volume to find the density. So when we're looking to calculate density, you always divide mass by volume. Here's a nice little trick. It's not a formula. It's not a way to write an equation, but it's a way to help you identify which way we should write our equation. You make a T, and then on top of the T you put an M. On one side of the capital T line you put a D for density, the other side is volume. You cover up with your finger whatever you're looking for, and then whatever's left over you decide if you're going to multiply or divide. So if I'm looking for density, I notice if I cover up that D, there's an M on top and a V on the bottom. So because there's one thing above the line and one below, we call that division. If I want to find the answer for mass, I would cover up the M, and I notice both of the numbers I have are below the line. So now I can multiply density times volume to find mass. Whenever you do a problem for this unit, you must show the actual formula you write. So you would go D equals M over V, or M equals D times V, or V equals M divided by D. You will then show your work and you will have an answer with units. If those three things do not get done, proper formula, work, answer with units, you will get a 0 for that problem. We will have many problems on our density worksheet, on our density labs, and you must do these steps so I can identify you understand the formula. All right, section 2 questions. The first question was asking how much mass is measure of how much matter is an object, while what's the difference with weight? Remember, weight is a measurement of the force of gravity. Depending on where you are in our universe, there will be a lot of gravity or a little bit of gravity. Question 2 is asking you what quantities are needed for density, and they are mass and volume. Question 3 wants to know, how do you measure the volume of an irregular object? So remember, that's where you're going to start with your container. For us, it's a graduated cylinder. You will put in a set amount of water. You then place the object carefully, subtract the initial volume from the ending volume, and that difference is the volume of the object. All right, in question 4, they gave you some information and they wanted to know if that object was made of aluminum or not. So the density of aluminum is 2.7 grams per centimeter cubed. So remember, you take the mass and they gave you 52 grams. You divide it by the volume they gave you, 17.1 centimeters cubed. It came out to 3.04 grams per centimeter cubed. So no, this is not aluminum because it does not match the density. It is another metal object that has a faint silver look to it. All right, when you're done with this, go back, check your answers. Whatever you need to correct, do so in your notes. Have a great day.